All right, we're starting a new unit, electric forces, fields, and potential. First section we've got is called charges. To begin, how do things get a charge? Well, for something that's positive, it has to lose electrons. For something that's negative, it has to gain electrons. So remember, electrons are the particle that are the subatomic particle that can move. Protons can't move. Back in the day, they didn't know the difference of whether negatives were flowing or positives were flowing because it looks the same on a macro scale, just opposite. So they came up with positive current. That'll get annoying later when we get into circuits, but for now, it doesn't have too much to do. One thing we know about charges is that likes repel and opposites attract. So if I have two negative charges, they're going to repel each other. If I have two positive charges, they're going to repel each other. Wonderful. And if I have a negative and a positive, they're going to feel an attractive force between them. Up next, let's say I've got some kind of sphere that has a charge on it. This one's got, let's say, 6 positive charges, a net 6 positive, and this one has a net 0. In one case, what I'm going to do is I'm going to put a nail on it. So let's come over here. Here's my charges again. But now I put a metal nail across them. And what I end up with are 3 positive charges on each because 3 electrons worth of charge flowed over here. And now this one has a net positive 3 charge because charges like to balance. In this case, this thing is what we call a conductor because conductors allow charges to flow. And then another case, let's say I've got a hunk of wood connecting them. A hunk of wood does not allow the charges to flow. That is what we call an insulator. No charges flow. Now, in real life, you can get some charges to flow, but they tend to resist the majority of it. So unless you've got a really high voltage across it, it's not going to happen. So let's make a chart real quick. We've got our conductors. This is number 4 as well. We've got conductors, insulators, and semiconductors. All right, so in these ones, electrons flow easily. In insulators, electron flow is resisted. And for semiconductors, it's going to have properties of both. Conductors and insulators. So they can be changed based on the situation. We're not going to get too much into it. Just know that it can have the properties of both. So examples of conductors are metal, dissolved ions, and in my case, unfortunately, skin, because I have an extremely low skin resistance, meaning I get shocked. So if you're sweaty, it happens to you too. Things that resist electricity flowing are things like wood, plastic, rubber, and water. So people don't realize it. They always think, oh, get out of the water, lightning's coming. Well, that's because most water you swim in has a bunch of dissolved ions in it. Ions are things with a charge. So when lightning strikes it, it can flow because that charge can move. If there's no charges in it, water's a neutral compound. nothing's going to happen. But because water dissolves things in it so easily, that's why it tends to be dangerous with electricity around it. And finally here, what are some examples of semiconductors? There's like silicon, germanium, most of the metalloids on the periodic table. If you remember that from chemistry, most of the metalloids are going to be your semiconductors. So let's now, since we've talked about what charges are, how you get them, how you lose them, how they can flow, let's real quickly just talk about how we can build up a charge or, so the ways, and this is number, what is it here, 5? Ways of charging. The first one we have is conduction. We have induction. And we have friction, which is similar to conduction, but not exactly the same. So in conduction, you transfer through contact. That's like over here in this example, when we put the nail on it, it was in contact with both of them. It allowed charges to flow through. This had a higher charge density. Charges always want to even out their spread so that there's not a higher charge concentration in one place. Just like energy and heat want to flow out and evenly distribute themselves, charges want to do the same. Induction, so this is where you bring a charged object close, then ground the initial object. So this would be like if I had, I don't know, a piece of metal and I bring a balloon that I've charged up near it. The balloon, whatever charge it has, it's going to push away that same charge in the nail. Then if I touch the nail, I am a source of a lot of electrons, so it's either going to allow more electrons to flow into me or a source to flow out, whatever the balloon needs. Then when I pull the balloon away while I'm still touching it, it's got excess, I move my hand away and then pull the balloon. The balloon now has the nail has excess charge. Let me draw a quick picture to show you guys what I'm talking about. Let's say here's my nail. There's my balloon. Let's say my balloon has a bunch of extra negatives on it. What's going to happen is it's going to push all the negatives away because they don't want to be in this nail. They want to get out of there because there's a bunch of negative charge there. Remember, opposites repel. So if I've got a bunch of negatives in there and they want to get out, and then I come over here and I touch it with my hand is a source of electrons or a source where electrons can flow. So what's going to happen is all the electrons are going to flow out of it. Now I pull my hand away. It's still slightly positive because of a bunch of electrons float out. If I remove the balloon and pull it away, those missing electrons are still gone. They can't go anywhere. So this thing is left over with an excess positive charge. So that would be through induction. And finally, like we said with the balloon, this is through rubbing or peeling. And we'll see that with one of the labs that we do in just a little bit. That you can build up a charge by removing electrons physically by rubbing them off or by peeling them off using something like tape. And that'll be the notes on charges.